Alright, this video is to help you solve problems with calculating the empirical formula of a compound. Now, the empirical formula of a compound is the simplest or lowest ratio of how the atoms combined in a compound. Now, we're going to talk tomorrow about something that's called the molecular formula, which is related to the empirical formula, but it's a multiple of it. Today, we're just talking about the lowest or the simplest ratio of how the atoms combine. I just did a quick example of how you might see this is when you're cooking rice. One way to usually make it, depending on which type of rice you use, is to use 1 cup of rice for every 2 cups of water. All right, now if you wanted to make a double or triple the amount, all you have to do is multiply how much water you need. So like for example, if you want to double the recipe, you would just have 2 cups of rice and 4 cups of water. But the simplest ratio is still 1 cup of rice for every 2 cups of water, regardless of however or how much rice or water you have. The simplest ratio is always going to be 1 to 2. And that's what we're looking with the compounds. All right, let's take a look at the rules for calculating the empirical formula. All right, there's 4 simple rules we're going to follow. The first one is find the mass of each element in the compound. Now, if percentages are given, this makes it nice because you just say that the sample is out of 100 grams, so the percentages actually turn into the grams, so that's very, very nice. The second thing is you're going to do is divide each element by its atomic mass to convert it to moles. Then once you get it to moles, you're going to do step 3. Divide all the number of moles by the smallest number you have. Now, these numbers will be your subscripts in your formula if the number is within 0.05 of a whole number. If it's not, what we're going to do is move on to step 4, and we're going to have to multiply all of the subscripts by a factor so it becomes within 0.05 of a whole number. Alright, so let's take a look at a couple of examples. Here is example number 1. Alright, so if you have 14.04 grams of silver, it combines with an excess of sulfur. That just means it combines with a large amount of sulfur. And it produces 16.14 grams of a compound. Find the empirical formula of silver and sulfur. So what we want to do is figure out what is the simplest ratio that the atoms actually combine in. So the first thing we need to do is step number 1. We need to figure out, well, what is the amount of each substance produced. So we know the amount of silver. So for silver, that is 14.04 grams. All right, for sulfur, it's not given to us, but we can calculate it easily. If the compound is 16.14 grams, you subtract sulfur or silver from it, 14.0. Holy moly, this does not look right. We know how to rewrite that. It looks all sketchy. So if it's minus 14.04 grams, and we get approximately 2.10 grams of sulfur. So let's go ahead and let's start now. Once we have our mass, we can move on to step 2. Step 2 is divide each element by its atomic mass. So for silver, what you're going to do is you take 14.04 grams of Ag, and since we have grams, we want moles, you are going to divide by its atomic mass. Okay, and by doing that, you get a number of 0.130 moles. Let's do the same thing for the sulfur. For sulfur, we have 2.10 grams of it. Okay, and we look on a periodic table. Its molar mass is 32.1 grams per mole. We're going to flip that around, so 1 mole is on top, and the 32.1 grams of sulfur is on the bottom. My units cancel, and when I do that, I get about 0.0654 moles. Alright, so that's step 2. Now step 3 is take your number of moles and divide all of them by the smallest number. So what we're going to do here is the smallest number is 0.0654. So I'm going to divide this by 0.0654 moles. Alright, and I get 1.00. And I divide this by 0.0654 moles. Alright, the units of moles, they cancel out. So moles cancel out. And I'm left here with about 1.99. Now that's within 0.05 a whole number. So what we're going to do is we're going to round this up. So that actually becomes 2. Now these numbers right here, that actually is 1. These numbers right here are actually our subscripts for the elements. So for Ag, there's a 2. And for sulfur, there's a 1. But we don't have to put that. So my formula is Ag2S1. Or Ag2S. Take a look at example 2. Alright, so what we have to do is, if you have percentages, make your total mass about 100, and these percentages turn into the grams. So we already have that step. So for K, alright, we know it's 24.58%, so that means it is going to be 24.58 grams. Alright, and let's take a look at the manganese. Alright, for the manganese, we know that if we have 35.81%, that means we have 35.81 grams. And for oxygen, if it is 40.50%, it means it's 40.50 grams. Okay? Now what we're going to do is divide all of these by their atomic masses. So for potassium, I look on the periodic table, it's 39.1 grams per mole, so I want 1 mole, so I divide by 39.1 grams of it. Adios grams, and I'm left with moles, which is 0.629 mole. I do the same thing here for manganese. It's 54.9, so I flip that around, so 1 mole goes on top, divided by 54. Oh, there's like a 5. Let's undo that. There we go, that looks a little bit better. 54.9 grams, so adios grams, hello moles, and I get 0.652 moles. Alright, then for oxygen, we have 1 mole on top, and it's 60.0 grams on the bottom. Goodbye grams, hello moles, and I get about 2.53 moles. Alright, now we're moving on to step 2. Let's change colors a little bit. We did step 2. Step 3 says divide all of the numbers of moles by the smallest. So you look at these right here, you say, well, which one's the smallest number of moles? And it's this guy right here, the 0.629. So I'm going to divide all of them by 0.629 moles, and I get 1. Divide this by 0.629 moles. All right, moles cancel out. Okay, and I get about 1.03. I divide this by 0.629 moles. Alright, and that gives me an answer of 4.02. Now, if these are within 0.05 of a whole number, you're okay. You just round those down. So 1.03, that's going to round to 1. 4.02, that's going to round down to 4. Now, these right here are going to be my subscript. So for K, there's just 1, so you just write the K. For Mn, it's just 1, so you just write an Mn. And for the oxygen, it is a 4. And that is my formula, KMnO4. Alright, now it's very, very crucial that you follow significant figures. As if you don't follow sig figs and you start making up your own rounding rules, these numbers aren't going to come out correctly. And what's going to happen is you're going to get these wrong, even though they do the right thing. So make sure you follow significant figures. All right, on our periodic table, there's 3 here. Since I'm divided by 3, my answer will have 3. So that's how I would get 3 significant figures here, and here, and here, and also here, and here. All right, so just keep that in mind. All right, let's take a look at example 3. Is our last example we're doing. All right, so it says the compounds found that contain 72.3% iron and 27.7% of oxygen. Calculate the empirical formula. Remember, we like percentages, so if you have percentages, those are the easy problems to do. Alright, so for iron, we know that the mass is going to be 72.3 grams. And I'm going to divide it by its molar mass, so we're going to put 1 mole on top, and we're going to have 55.8 grams on the bottom. That cancels out, and when I take 72.3 divided by 55.8, I get 1.30 moles. We do the same thing for oxygen down here, and it's going to be 27.7 grams. And we're going to divide by oxygen's molar mass. Hopefully you know that one by now, which is 16.0 grams per mole. Goodbye grams. We're left with moles. I'm apologizing for my writing. It looks so wiggly today. I'm not sure what's going on with that. But we take 27.7 divided by 16, and I get 1.73 moles. Now, we divide both of these by the smallest number. Let's pick orange. I'm feeling orange today. Alright, so I'm going to divide both these by the smallest number. So the smallest number is 1.30, so I divide by 1.30 for the number of moles. That equals 1. Moles cancel out. Remember, this is going to be unitless because moles cancel. And divide by 1.30 moles on the bottom. It cancels out. And when I do this, I get 1.33. Here it's 1.00. Now, when we take a look at this problem right here, you say, well, this is okay. This one's all right. But then take a look at this one. This is not okay. This is not within 0.05 of a whole number. So you got to think, well, what can I do to get this a whole number? So what you do is you kind of take a look at these endings right here, and you got to think, well, what can I multiply 0.33 by to be close to a whole number? So you think, well, if I divide 0.33 by 2, it's 0.66. That's not going to work. 0.33 times 3 is 0.99, so that's what I'm going to do. So I'm going to take 1.33, multiply it by 3, and I get right here, so I'm going to multiply this by 3, and I get 3.99. Now, if you multiply, let me erase that a little bit, rewrite that. Now, if you multiply one thing in here, you have to do it to all of them. So 3.99. So I have to multiply this by 3 also, and I get 3. So that one's okay. That one is 3.99, so that's going to round that to 4. Alright, so these now are my subscripts for my formula. For iron, it is 3. For oxygen, it's going to be 4. Alright, and that is my answer. The only tricky part is right here, this is actually part of step 4. This extra part right here, multiplying by the numbers right here. So yes, this was when we stopped earlier, but since this ends in 0.33, what we have to do is multiply by a factor, both of them, or all of them in this case. If there's more, you have to multiply all of them by the same factor, so they're all within a whole number. Alright, the trick here is if you have a 0.33, you're probably most likely going to multiply it by factors of 3, and you're going to get that into something 0.99. If you have a 0.66 ending, alright, you're most likely going to multiply it by 3 also, because then that ending part of the number will be point something, you'll have an x, something 98, so 1.98, 3.98, doesn't matter. Alright, so you're going to end in with these. So just kind of keep that in mind. So if you have something with 0.33 and 0.66, multiply them both by 3, and you'll be in good shape. If you have something that ends in a 0.50, you're going to multiply that by 2 to get that to a whole number. So something 0.00 it'll end in. If you have a 0.25, I'm sure you're probably going to figure that out. Then you multiply it by 4. Then you're going to have some number times 0.00. So it'll end in a whole number. Remember, you want to be within 0.05 of a whole number. Okay, if you have any questions, please let Mr. Kleinschmidt or myself know, and we'll be more than happy to help you. All right, good luck. Hopefully you get this. See you in class.